For our next set of problems, we are asked to simplify the following radicals. Some problems have simply the square root and some of them has the cube root with multiple different things, like we have a mix of numbers and letters. For example, in this one we only have numbers and letters, but we also have different types of letters. Like in this one we have X, Y, and Z, and also a number. So let's start. For the first problem, we have square root of 75 multiplied, since they're together, that means multiplied by x to the power 2. One approach that we could apply, since the number and the letter are multiplying inside the root, we could actually separate them into each one having its own root. So we're going to have 75 times square root of x squared. So we could do that because they both are inside the same radical, okay? And again, our index, since index is not given, automatically is going to be number 2. Now, what is the square root of 75? 75 turned out not to be a perfect square number. That means that there is no an exactly square root of 75. It's going to end up with a number and a square root as well. Let's do the prime factorization for 75. Okay, so it's going to be 75. Notice that it ends in 5. We could break it down as 5 times 15. And you may ask, how do I get 15 here? Notice the 75 ends in 5, so it has to be divisible by 5. If you divide 75 divided by 5, gives me 15. That means that 5 times 15 gives me 75. Now, let's break it down 15 as well, because 15 we could actually break it down into 5 and 3, and bring the 5 here. Notice, our index is 2. So we are basically looking for one number that could be raised to the power of 2 as well, same as our index, and we have found it already, which is 5. Because 5 times 5, we could rewrite it as 5 squared times, and then bring down the 3. So 5 squared multiplied by 3 gives me 75. So 75, I could rewrite it as 5 squared times 5, and bring down the x squared. Notice that x squared, I rewrote it the same because this eventually will cancel, because in this case, I already have the same index and the same power. So this radical will cancel. So I'm just gonna left out with x. Multiplication, okay? So notice here, we have 5 squared. This one's supposed to be a 3 right there. So we have 5 squared multiplied by 3. Notice that they're multiplying again, right? So we could actually separate them into each one having its own separated root, and then times x, which I already simplified. So here, notice here, these two with these two will cancel. Same index, same exponent cancel. So I'm left out with 5. This 5 is going to multiply, notice that 3. The power of 3 automatically is 1, which is less than our index. So we cannot simplify that 3. So this 3 will stay inside like this. So you cannot simplify and bring down the x. Now let's multiply the things that are outside of the square root, which is the 5 and the x. And we could bring those in front of the square root, which is the common way of writing our answer. So it's going to be 5 times x will be x, and write down the square root of 3 at the end. And that is going to be our solution. For our second problem, we have square root of 40, x cubed, and y. Again, they're next to each other, so that means that they're multiplying. So the first step that we could take is to separate them, each one having its own square root. So 40 here, x power 3 here, and y here. Now, so how do we simplify a square root of 40? let's do the prime factorization of 40, right? Let's do it here on the side. So we have 40. We have 40, that is a times 5. Or you could also do 4 times 10, which is, I think, easier. But this will also work. And 8, we could rewrite it as 4 times 2. And 5, we can rewrite it only 5 times 1, but it doesn't count. And then the 4, we could break it down further into 2 times 2, bring that 2 here, and then bring the 5, which we cannot simplify more, right? Or factor more. So 40, I could rewrite it as 2 times 2 times 2 times 5. But notice here, our index automatically is 2 in each one. So I need some number to the power 2 from the prime factorization here. So I could get these two numbers right here, 2 times 2, and rewrite it as 2 power 2. And then bring that 2, and then bring the 5. So 40, I could rewrite it as 2 power 2 times 2 times 5. That will give me 40. So 2 power 2 times 2 times 5. Now, let's go over the x power 3. X power 3 simply means multiply the x 3 times. So that means x times x times x times, and that y, since our power of y is 1, which is less than 2, it cannot be simplified. So this one is going to remain inside the root. Now notice here, I have 2 power 2 times 2 times 5. I could separate them into each one having its own root. So I'm going to have 2 power 2 times 2 times 5. And then let me bring the rest. Now, in here, I have x times x times x. And my index is power 2. So I could take a pair of x times x and rewrite it as x power 2. And then I'm left out with an extra x there. And bring down the y here. So this one is for node only. Now notice, my index is 2 here, automatically is 2. Power 2 will cancel here, so I'm left out with 2, right? Now, this 2 has power 1. My index is 2, so it cannot cancel. So this one will remain inside the root. The same thing happens for 5. The power of 5 is 1. My index is 2, so power is less than 2. So that one will remain inside. Now let's go to the next item here. So let me rewrite the 2 here, which will remain inside. The 5 also will remain inside. And then x to the power 2 times x. Again, I have two things here. I could separate them into each one having its own square root, right? And bring down that term with y. Now, notice that I have the square root of 2 here, square root of 5 here, which cannot be simplified further. Also, I have the square root of x here that cannot be simplified further because my power is 1, which is less than the index. And also, this y here. So I have 1, 2, 3, and 4 things that cannot be simplified. But they'll have the same index, index 2, index 2, index 2. And everything here is multiplying. So what I can do here, I could put them in one single root and multiply each one inside that single root. Okay, so I'm going to have that 2 here. So these 2 multiply times 5, multiply times this x, and multiply times this y. Now this one, same exponent, same index cancel. So that will be actually outside of the root because this one, since the power cancel with the index, so the x will be outside. So this x that is outside is going to multiply these 2 that is actually outside. So we can bring it in front of it. So I'm going to have 2x, a square root of 1. And then I multiply this, right? 2 times 5, 10, times x times y come together. And that's going to be my final solution. The next problem, we have cube root of 16 x power 6 y power 4. Let's approach this in a different way. It's not that different, but it's very similar to the previous one. So first thing, that we could do is to do the prime factorization of 16. Okay, so we have 16. 16, as you might know, factorized as a times 2. And then 8 to factor as 4 times 2, bring that 2 here. And 4, we could break it down into 2 times 2. So 16, it's 2 times 2 times 2 times 2, which is basically 2 to the power 4. But notice here, our index is 3. So that gives us a hint that we're looking for some number to the power of 3. So we could take the first 3 numbers here, because they're the same, and rewrite it as 2 power 3, and bring down the one that is left. Then 16, I could rewrite it as 2 power 3 times 2. I need a power 3 because my index is 3 as well. So 16, I could rewrite it as 2 power 3 times 2. X power 6 means multiply x by itself 6 times. So I'm going to have x multiply 6 times. But I could break it down into powers of 3. Why 3? Again, because my index is 3. So x power 6, I could break it down into x3 times x3. Because 3 plus 3 gives me 6. Again, when you multiply the same letters, the exponents add. So 3 plus 3 gives me 6. Same approach with the y to the power 4. I could break it down into one of the y's with the same power as my index. So y4, I could break it down into y3 and y to the power of 1, because 3 plus 1 gives me 4. Now notice that 2 has power 3. This x has power 3, this x has power 3, and this y also has power 3. That means that anything with the same power as the index is going to go outside. So all of these are going to go outside without the exponent again, because the exponent will cancel with the index. So that means these two will go out, this x will go out, and whatever goes out is going to multiply each other. This x will go out, which is this x. This another x will go out, which is multiplied by x again. And then a y will go out, and that's going to multiply whatever goes outside as well. Now these two and this y power 1 will stay inside because they cannot be simplified anymore. Because this the power of 2 is automatically 1, which is less than the index, and the same thing for y. We have 1, which is less than our index. So those are going to stay inside, which is 2y, and don't forget to write the index right there. Now we just multiply 2 times x, that will give me 2x squared y, and bring down whatever you could simplify, which is the 2 times y, and that's going to be our final solution. For problem number 4, we have cube root of 54 x power 2. From the beginning, you should observe that the power of x is 2, and my index is 3. So this one is less than my index. That means that this x squared cannot be simplified at all. So this x squared will remain inside the root. Now, let's focus on 54. Let's do the prime factorization of 54. So you might know 54 is 6 multiplied by 9. And then 9, we could break it down into 3 and 3, because 3 times 3 gives me 9. And 6, we could break it down into 2 and 3. Again, my index is 3. So I need to get somehow a number to the power of 3. As you might see here, we already have it. That means that I could rewrite 3 times 3 times 3 as 3 to the power of 3, and then bring down that 2. So 54, I could rewrite it as 3 power 3 times 2. So 3 power 3 times 2, and then don't forget the x squared. Again, notice that the power of 2 automatically is 1. So these two items right here, the 2 and the x squared, they cannot be simplified because each power is less than our index. But notice that 3. The power of 3, which is 3, is the same as the index of the root, which is 3. So this actually is going to cancel with this one. So this 3 will go out outside the root. And that's the only thing that will go out. The rest of it is going to stay inside. And remember, the 3 will go out without the power of 3 anymore, because this power 3 cancel with this one. Okay, so that will be our final solution. For problem number 5, we have 128 x y to the power of 6. As you might notice, our index is not given, so automatically it's going to be 2. Now, let's do the prime factorization of 128. Let's do it here on the side. 128 is nth 8, so it has to be a factor of 2. Or, let me give you a trick that you could use. The first thing that you should notice is that it's an even number. It's nth 8, so it's an even number. So you could break it down into 2 parts. Let's break it down into 12 and 8. And then you could say half of 12 is 6, and half of 8 is 4. And half means that I'm dividing each number by 2. So 128 is simply 64 multiplied by 2. Now let's keep simplifying or break it down to 64. So let's break it down to 64. 64, as you might know, is a times a, and then bring that 2 here. Notice that we have an index of 2 here. So we need some number to the power of 2 when we break 128 out. And we will have already found it, which is 8 times 8. Because 8 times 8, I could rewrite it as 8 to the second times 2. Because 8 to the second, or 8 power 2, is 64, times 2 gives me 128. Therefore, 128, I could rewrite it as 8 to the power 2 times 2. Bring down the x, and the power of x is 1, which is less than the index, so that one is not going to be simplified. So x will be stuck inside the radical. Now, y power 6. Y power 6, let's break it down with powers of 2. That means I'm going to have y power 2 times y power 2. So far I have 4. I need 6, so I need to add another 2. Because 2 plus 2, 4, plus 2, 6. That gives me y power 6 when I multiply y squared times y squared times y squared. So remember, when you multiply the same letter, the exponents add. So 2 plus 2 plus 2 gives me 6. Again, anything with power of 2, which is the same index, will eventually go out. So this a will go out, this y will go out, this y will go out, and this y will go out. So 3 y's are going to go out, and they're going to multiply each other, and the 8 as well. So I'm going to have a times y times y times y, and then inside I'm going to have the 2 and the x. And y times y times y, again, each y has power 1. So when you multiply the same letter, the exponents are. So 1 plus 1 plus 1, 3. So I'm going to have y to the power of 3. And inside, the 2x. And that's going to be our final solution, because 2 cannot be simplified and x cannot be simplified as well. Because my index here automatically is 2, and the 2 power is 1, and the x as well, which both are less than our index. So that's going to be our solution. For our next problem, we have cube root of 32x cubed y4 z power 5. Let's begin with the number. Let's do the prime factorization of the number, and let's see if we could get a number with some power of 3, because our index is 3, so our goal is to obtain a number with power 3. So let's start. So 32, we could break it down as 16 times 2. 16, we could break it down as 4 times 4. bring down that 2 that is there. Now, we still don't have something power 3. We have something power 2, right, which is 4 times 4. But we need something power 3 because our index is 3. Now 4, we could break it down into 2 and 2. That other 4, we could also break it down into 2 and 2 and bring down that 2 here. Now, we need something to a power 3, right? So we have already found it. This number here, 2 times 2 times 2, which is 2 to the power 3. And 2 times 2, since 2 times 2 is to the power of second, we're not going to be able to simplify it further. So we could just rewrite it as 4. So 32, we could rewrite it as 2 power 3 times 4. Next, let's rewrite x to the power of 3 because this 3 is already with the same index as 3, so we don't need to change anything. Now y power 4, I could break it down as y3 and y1. y3 because I need something with power 3 because my index is 3 as well. So y4, I could break it down into y3 and y1 because 3 plus 1 gives me 4. Same thing for z to the power of 5. I could break it down into z to the power 3 because my index is 3 again, and z power 2 because 3 plus 2 gives me 5. Now, the things with exponent 3 are the ones that are going to go out. Like for example, these 2 will go out, this x will go out, this y will go out, and this z will go out. So that 2 will go out, the x will go out, this y will go out, and this z will go out. And again, without the exponents because the exponents are being cancelled with the index right here. And the inside, I'm gonna left out with, no, this is not index 4. It's index 3. And inside, I'm left with 4, y, and z2. And that's gonna be our final solution. For our final problem in simplifying radicals, we have a radical with index 3, and inside we have negative 24, x power 4, y to the second, and z power 6. From the beginning, notice that this y with power 2 will not go out or will not be simplified because the exponent of y is less than the index, which is 3 in this case. Let's work on the number 24 for now. Negative 24. Let's break it down, right? We have negative 24 here. So negative 24, we could break it down as negative 6 and 4. And negative 6, we could break it down into negative 3 and 2. And 4, we could break it down into 2 and 2. Now, our index is 3, so that means that we need some number to the power of 3. And that number is going to be 2 to the power of 3 because we have 2, 2, and 2. That means that we could rewrite it as 2 power 3 times negative 3. That will give us minus 24. But here is the tricky situation that we have. We could also make that 2 negative and keep that 3 positive. Okay, and let's do that better. That means that we could do the 2 as negative with power 3 and the 3 become positive. Why? Because any number negative that is raised to a power odd, our answer will always be negative. So for example, negative 2 to the power 3 means negative 2 multiplied by itself 3 times. That means negative 2 times negative 2, that will give me positive 4. And positive 4 times multiplied by negative 2, that will give me negative 8. And this negative 8 multiplied by 3 also gives me minus 24 or negative 24. Therefore, it doesn't matter into which number to put the negative. But preferable, let's give the negative to the number that is with some exponent bigger than 1, in this case 2. So minus 24, we could rewrite it as minus 2 to the power 3 times 3. that will give us minus 24, like I show you here. Now, x power 4, we could break it down with one of the x having exponent 3. So I could rewrite it as x to the power 3 times x to the power 1. That will give me 4 because 3 plus 1 gives me 4. Y2, I cannot, there's no point of breaking it down because it's gonna still remain in the inside because the 2, this exponent is less than our index. Now Z6, I could break it down into 3 and 3 because 3 plus 3 gives me 6. And again, anything with power 3 is going to go out of the radical because my index is 3. So this negative 2 will go out. It's going to multiply this x that also will go out. Okay, again, when it goes out, it's without the exponent, okay, because this exponent is being cancelled. Same thing for this one. This z will go out, is going to multiply wherever it goes out as well, and another z will go out. And inside, I'm going to have the 3, the x, and the y squared. So it'll be 3x y squared. And in here I have negative 2 times x times z. These two z's that are multiplying each other, I could rewrite it as z power 2 and bring down the rest of our solution. And that's going to be our final solution.